are going to discover how to generate synthetic motion data for imitation learning using NVIDIA's GR00T Mimic. But first, let's clarify what these terms mean and why it's quite a big deal. Hi, my name is Momir, also known as Lychee AI. So, imitation learning is used to teach robots to perform a task using AI. Unlike other approaches like reinforcement learning, the robot learns with examples. These examples are trajectories, which capture the motion of robots' joints or end effectors. Now, collecting data from real robots can be quite expensive, slow, and sometimes also risky. That's where synthetic data comes in. With NVIDIA's GR00T Mimic, we are able to create this training data in simulation at scale using just a few human demonstrations. For this, we are leveraging NVIDIA's Omniverse Isaac Lab, which is made for training robots in simulation. In a previous NVIDIA livestream, we demonstrated this workflow using a robotic arm, which is being teleoperated by the real robot, sending information of the robot's position to the simulation. Here, we first collect 10 human demonstrations for the stacking cubes task. From these demonstrations, GR00T Mimic, like the name suggests, mimics these demonstrations using interpolation, whilst applying randomization and action noise. As we're in simulation, we are able to scale these running many environments in parallel, effectively generating thousands of synthetic motion data in just some hours. After saving only the successful demonstrations, we are now able to train imitation learning models, which generalize to these tasks. We are also able to generate synthetic visual data, which allows us to train world foundation models like NVIDIA's GR00T N1.5, which takes in visual, language, and state data to output the intended robot motion to perform a task. As you may imagine, the simulation environment may not mirror the real world accurately. For this, NVIDIA has also integrated Cosmos into the whole pipeline. Cosmos, or in our case Cosmos Transfer, is another world foundation model but meant for visual augmentation. Using Isaac Lab, we are able to generate all types of metadata, such as RGB, segmentation, or depth, which allows us to generate highly realistic and controlled scenes to further close the sim-to-real gap for physical AI. Combining all workflows together, we are now able to generate thousands of synthetic motion as well as visual augmented data, which is not only saving a lot of time, but may also be better than real training data, as we are able to randomize physical parameters and augment visual data in simulation. If you're interested in implementing GR00T Mimic into your workflows, reach out to FS Studio.